Hello everyone. Today we are going to solve a problem known as Morris in-order traversal. Okay, let's go through this problem once. So what is Morris in-order traversal? It's simply an in-order traversal, but we mostly do it recursively, and that's easy also. But in this, we have to do this problem. We have to solve this problem iteratively. The idea is very simple. Just start from the root. In case there is nothing on the left, go to the right and keep on going to the right. Simple. Okay, but in case there is something on left, go to the left and then again go to this its rightmost part. Okay, once you are at the rightmost part, just connect that rightmost part to the root. Okay, so let's see over here, like you are at 1. Now you have to on left, on there is 2. Okay, first we have to check there is something on left or not. In case there is nothing on left, then it's really very easy problem. Right inclined, keep on traversing 1, 3 and so on. But in case there is something on its left, so go to the left part. Okay, like keep a counter on this route. Make a copy of, like make another counter, uh, like you have kept this route, okay, intact. So now just have something, any other pointer. Let's take a previous name. Okay, prev. So now just now your previous count is at 2 and root is 1. Now go to the prev's most right part, that is 6. Okay, and connect this to the root. Simple. Similarly, now shift your, yeah, shift your root to the left and do the same for this. Okay, this is very simple. And when you are at this part, just simply do one thing, that is print this part and move to this. Print this and move like this. Yes, and in case you are like going through this iteratively and you found that prev का जो right है, right of prev is actually pointing to the root, then there's a problem. So simply do one thing, that is we solved that problem once and we are coming again to into it. So just do one thing, just remove this connection. Okay, and insert this value into, sorry, print this value and now move your like root to left. Simple. Okay, now to make this more simpler, I got this problem. In this problem only just think of 2 cases and I think this problem will be good to go. Okay, so let's see what's going on. We have to return a list of integers. Okay, let's create then. uh, so let's call an helper function which will return a list and we will be done. Okay, so list we have to return, let's keep that name as a answer. Okay, okay, now let's call a function in which we will passing root comma answer and we'll be returning this answer also. So let's create now helper function. Define helper, right? So self comma root we are taking as input and answer, right? Now we have to do just one thing, while your root while root is not equal to none, until and unless our root is none, we have to now check condition that is there something on right and left. Okay, now first let's solve this case 1. Okay, like you can see, if it is right inclined, it is very simple to solve. It means there is nothing on left, that is if root dot left is none, right? If root dot left is none, so just do one thing, answer dot append. आंसर में क्या append करना है, root dot val, right? We have appended root dot val. Now in case root dot left is not null, yes, this could be a case, that is case 2. But before that, root is equal to root dot right. In case there is nothing on left, it's right inclined, it will continue and finish here only. But else, if there is something on left, so create a um, create a pointer which is at root dot left. Okay. Now what we have to do, now go to the rightmost part of this priv. Okay. While priv dot right is not none, what we have to do, priv is equal to priv dot right. Okay. And we have to check one more condition. It could go to right, it's not none, and priv dot right is not pointing to root. Okay. Now if priv dot right is none, okay, if it is none, what we have to do, we have to make connections. Okay, that means priv dot right is equal to root, made this connection, and priv dot right is none, like root. Okay, and we have to shift root to the left. Root is equal to root dot left. Simple. What if priv dot right is not none, that is priv dot right is equal to root, so this will be coming in else part. Okay. Now in case priv dot right is not equal to root, do simply one thing. At first remove connection. Dot priv dot right is equal to none. First thing done, connection removed. Okay. Now answer dot append, क्या append करना है, root dot val, right? And one last thing we have to do, that is we have to move our root to its left. Okay, root is equal to root dot left, and we are good to go. Now since we pass this answer and it contains, since we did pass by reference, so we can use here. So let's try this if it's running. Wrong answer. Okay, okay, let's see what's the problem. Hmm. So problem we are facing is, okay, 1 here is null, okay, 2 and 3, okay, it's this tree. Okay, and the output is, okay, Inorder Traversal, right? 3 2, okay, 1 1 3 2, right? And what we are getting, 1 3 2 and 3 again. Okay, so quickly check this out. Where's the problem? Okay, so the problem was like we reached its end and we moved to the left part, whereas we were traversing for the right part. Okay, so now it's done. So let's wrap up this video. In next we will be going through problems. Let me tell in advance. Okay, we can go for top view. Okay, see you in next lecture. Thank you.